Alright, I thought I would just sort of begin the lecture with a little swing. We had a kind of an exercise that involved some file I/O, and I'm going to declare chapter 15, which is on streams, to be basically done. We've seen the output stream and the input stream, file input stream and file output stream, and zip output stream. We probably don't need to do anything with the readers and the writers now that we've seen the streams. And then I thought I would just zip through swing. I'd like to just get a show of hands. Who here has done a little swing programming before? Raul, no swing? Not really? A little bit. Okay. And so I thought I would just say, you know, swing is a lightweight AWT that goes on top of the heavyweight AWT. Do people know the difference between a lightweight AWT and a heavyweight AWT? I'll just ask. Sarah, you're at the top of my list. Not sure. Okay, Sushmita, you're up next. Excellent guess, but wrong. So maybe I should tell you. So that's 2 for 2 we got here. I don't know, and wrong guess. For the next victim, Sarisha, would you like to tell us? What is it? No. Okay, don't know. All right. So an AWT is heavyweight because it uses the built-in operating system graphic user interface. So when you program in the AWT, your program does not change. But when you go to create a standard file open dialog box, it looks like a Windows Microsoft Foundation class library standard file dialog box if you're on a Windows system. It looks like an X Windows standard file open dialog box if you're under Unix and running X. And it looks like a Macintosh standard file open dialog box if you're on a Macintosh. So presumably you like the look and feel of the operating system you're running on when you're using AWT. If you want portable look and feel, then you can actually create a completely soft GUI that's totally portable, and that's what swing is. So when you're on a cell phone from Nokia using J2ME, which is the Java 2 Micro Edition, you don't get swing. It's not included because it has JAVAX, I'll call it JAVAX extensions. It's a Java extension. It's not part of the core, which means it doesn't have to be deployed into your mobile device. So if you want to program your Nokia cell phone, you don't use swing. You use the AWT and you use whatever GUIs that they have, and you accept the way they look, and that's sufficient. Remember, people were programming cell phones long before Google, right? They were programming in Java too, before Google, because Google is a relative latecomer relative to the web, and before that there were people with Java on cell phones, and in fact the vast majority of the virtual machines being sold were being sold for mobile. Right? We don't need Apple to program cell phones. That we know for sure, unless it's an Apple cell phone. So swing has got a much richer set of features than the standard AWT. The other thing is, in order to be able to obtain I'll call it uniformity of the AWT from the programmer's point of view, you need what are called peer methods. Peer methods are methods which are based in the toolkit, the AWT toolkit, so that every programmer's program can port, and when you make a new instance of a file dialog, it looks like the same code on every platform, even though the graphic user interface appears differently. So for your code to become portable, you need a portable operating system software interface library. That's the peer methods. So AWT comes with a series of peer methods that map to the heavyweight methods. If you mix a swing with AWT, unpredictable results can occur. The reason why is because the refresh for the lightweight components happens differently than the refresh for the heavyweight components. So when the two overlap with one another, things don't happen the way you expect. If you use Java 3D, you're using a heavyweight API, because Java 3D gives you a canvas that gets rendered to directly by the hardware. So if you try to mix swing with Java 3D, you have to be very careful to keep your panels, your swing panels, separate from your Java 3D canvas, or else you're going to have results that are not reasonably predictable. And yes, I am in class. So when we look at the swing class hierarchy, we see a whole bunch of, I'll call it subclassing going on. And in that subclassing hierarchy, we can expect all of the methods in the superclass to be inherited by the child of the superclass. So when people use the unfortunate term component in the swing sense or in the AWT sense, they're referring to an AWT component or a J component, depending upon whether it's a heavyweight component or a swing lightweight component. And the container is a container of components. And then we have these interesting and wonderful problems that come about from reusing the term component. It's very complicated. When somebody uses the term component software development, they don't usually mean GUI development. Component software development in Java refers to the Java bean. Component software development in software engineering refers to the Industrial Revolution. It refers to interchangeable parts. It means that the component can be plugged into the system or framework and reused. So component software development is the software engineer's mechanism for doing software reuse. But when they start to talk about a swing component, then you know that you're in the GUI. So reusing the term is unfortunate, but it can be, I'll say, disambiguated when taken in context. I don't know why I'm getting a spinning beach ball of death. Do you see that? It's sort of, why is it doing this? I feel like something bad is happening to my computer. Maybe I should sort of get out of IntelliJ. Is that, you think it's doing something in the background? I can't imagine what that is, but I'm afraid. Oh, it stopped. Okay. Something in the back. What could it be? I don't know. So let's see. We know about AWT. Java AWT is a core API. JavaX.Swing is not. Core APIs generally will appear in your mobile device, but the JavaX APIs will not. There's a wide variety of different dialog boxes available to us. You've probably used some of them. The combo box gives you a list of choices. In AWT they call it the choice menu. In Swing. They call it the combo box. They both look very similar to one another. This is a pop-down choice menu. There's your friendly neighborhood progress bar. I should use more of those, but I don't. I prefer to just use print statements because that's good enough for me. But if you wanted to make it nice, you'd use a progress bar, even for your homework. And I guess giving you a little dynamic feedback on the progress bar is a good thing. Has everybody here tried a progress bar? There are two kinds of progress bars, determinate and indeterminate. The indeterminate progress bar just scans back and forth like a Cylon from Battlestar Galactica. The indeterminate progress bar has a percentage complete, and then you update the percentage complete in order to be able to show how far you've gotten in your system. So if you know in advance you have 4,600 files and you want to compress them all, then you can set it up so that when you get to 4,600 files it'll be 100%. Then the question becomes, how frequently should you update the progress bar? I think if you haven't seen any response from your program in 5 or 6 seconds, it's time to update. It's a very good thing if you can have a progress bar that always moves with monotonic increasing effect. So that means progress bars shouldn't go backwards. Right? If the progress bar is... I've seen this happen before. When you're downloading a big file, it seems like you're 90% done, and then you look up and now it's 80% done. And you think, how could this happen? I like updates. Regular updates are good. They don't take too much time from your CPU. If you overestimate and you sit there at 99%, or it says it's 100% done, and then it just sits there for 10 seconds, people will think, okay, your program is hosed. And yeah, progress bar should never decrease. Some fairly complicated things can happen in Swing. For example, spreadsheets. Spreadsheets are really complicated in Swing. You need a spreadsheet model, a spreadsheet view, a spreadsheet controller, JTrees. You know, spreadsheets they're all part of JTable. JTrees that are also pretty complicated, almost as complicated as JTables. The other stuff is pretty straightforward, I think. Let's see now. If you know the minimum and you know the maximum, then when you go to set the progress, you should be able to get a definitive progress bar. And there's a bunch of progress bar methods, and you can go through and just try and use them. I think it's pretty intuitive. And here's a little progress bar demo with a couple of text fields showing the from and to, and then the copy file gives you progress. Oh. Sorry. There are certain things that you can do that I find to be, I'll call it, generally useful. Setting up a menu is just generally useful. I love to set up menus, especially if I have many features. One of the things that I think is interesting about setting up the menu is that inside of a menu you can have another menu. Inside of that menu you can have yet another menu. And these are called hierarchic menus. So with hierarchic menus you can organize the operations that you'd like to perform. So if you say, well, let's do it, here's a menu for image processing, here's a submenu for edge detection, here's a whole family of edge detectors. You know, here's another one for filtering. I have low-pass filters. Here's the low-pass filter family. Bandpass filters, bandpass filter family. High-pass filters, high-pass filter family. You can go all the way down with color and all these other things. Menu items really let you explore all the different options. You keep adding features, and it doesn't really have to clutter up your interface much. So that's kind of neat. J pop-up menus I hardly ever use. You can usually mouse right and see a pop-up menu just come right up in the middle of your interface. IntelliJ does that. You know, with IntelliJ you can mouse right in the middle of your editor and you'll just get a pop-up menu. You could probably see that from IntelliJ right in here. Mouse right and you get a pop-up menu. And then over in here you've got a hierarchic menu. And there's another one, right? There's extract. So that's another hierarchic menu. Then this is a menu item. And you know this menu item is going to bring up a dialog box because it ends with ... That's the graphic user interface guideline. So if you want, you can actually get books on graphic user interface guidelines, or you can get books on graphic user interface guidelines just for Swing. So people have come up with these books just for Java programmers, which makes them perhaps even more relevant for you. These keyboard accelerators, they're global. And if you have two conflicting keyboard accelerators, it'll take the first one it encounters. In my system, it'll give you, I'll call it a warning, a dialog box when there's a conflict. For mnemonic keyboard accelerators like this X for extract, V for variable, you got something that's context driven. So it would be Alt X V, and that would bring up the variable dialog box. So if I say something like this, X V, let's see, didn't work. Oh, I guess it did work. Escape. Separators, they're horizontal bars that go across the menu for grouping things together. And then the menu items themselves, you can have radio button menu items and checkbox menu items. I don't really use that much. I find that to be a little bit over the top. I can show you what I do. If I do j2d GUI .main and hit run, what happened? Yeah, so this is your main menu bar, and then this here is a menu. Click on it, and now you've got another menu, and then over in here you got the menu items. Now what I can do is I can take each one of the menu items and I can assemble them into a panel. So when I say show histogram buttons, I would expect all of these menu items to become part of a panel that contains the buttons with the corresponding names. And there it is. So that can be done in a relatively automatic fashion. And that's convenient because then you can take the buttons and put them off to the side and start to check the buttons. You can click on them at random. This color swap, I could hurt my wrists if I just keep having to click into different kinds of color swapping. So showing the color swap buttons lets me take all of those menu items, put them off to the side. So now if I go to open up some sort of file, maybe an image, which perhaps I don't have, but I could probably find. There should be like images somewhere, just handy. I don't have any handy images. Don't they keep images like in the pictures folder or something? Desktop? Where are the pictures? There's no pictures here. Where else would it be? My documents? I don't have any pictures. I have no pictures. Libraries? Where do you see that? Penguins. Everybody likes penguins. That's a very nice looking penguin. So now if I want to, I can say R to gray, B to gray, green to gray, just get the red, or get the green, or get the blue, or swap green and blue, or swap red and blue. I don't know what this does. There's the panel. Oh, invert. That sounds like fun. What else you got? Just fun ways to sort of play with color. Oh, here's the histogram panel. Apply the histogram. Change the histogram equalization. So you get, sort of a way to experiment quickly with different operations. I sort of like that idea because it means I don't have to go in here and start to do things like pick out individual stuff, like the contrast panel, which maybe it's not a bad idea to play with. Change the brightness. So that's a nice way to go. What about this stuff on the side here? What's this? I can use the arrow keys for this. The arrow key will let me change the value. I can use arrow up or arrow down, or page down, or page up. Let's see, does page up work here? I think it should. Page up? No. But arrow up works. So what's that called? You never saw it before. It's a spinner. Right? Yeah, you're right. This is a slider. But this is a spinner. The underlying numeric value is the number model. This is both a controller and a view, and this is a controller, and this is both a controller and a view. I can just put in a number in here, and it updates the slider, the image that depends upon the value, and the text field. So if I wanted to, I could probably just say 0, enter, and that works. So what that means to me is if I want to say -2 and just hit enter, it just works. -255, 225, 255. I think it'll work. Yeah. And if you hit save, this will actually save that dialog box, so the next time it gets opened it'll come up with that value, which you might call reasonable defaults. It should remember the settings. Let's see, what else do we have here? Yeah, more edge stuff. So it's just menu items, but maybe there's more to it than that. Here is a bunch of menu items inside of menus. If I show the morphological filter buttons, it not only gives me all the menus, but it gives me all the menu items inside of all the menus. So these buttons kind of go on and on. I mean, there's just like a lot of buttons. But then you can just run around and try and click different things, like salt and pepper. And you can sort of see these little spots. The salt is the white spots, and the pepper is the black spots. There's probably thresholding in here, and skeletonization. That's going to take a while. I probably need a dialog box for that, right? Yeah, I screwed it up. Yep, there it is. It worked. Roberts filter. That actually looks pretty good. That's a decent edge. Centroid. That takes as long as skeletonization sometimes. Yeah, there's the centroid. So there's all kinds of interesting. These are called morphological filter functions because they change the shape of the image. But the message is not so much the image processing, but how you can organize all of the knowledge that goes into the program so that it can be available to you at your fingertips. That gives you real power, right, to organize the interface in a convenient way. Let's see now. What else can I say about it? Oh, these keyboard accelerators. You know, studies show that people think keyboard accelerators will make them faster, but the stopwatch proves that they are wrong. This is called confirmation bias. In experiments where you believe that you are faster, even though you are faced with evidence that you are not faster, you tend to discount that evidence and say it doesn't apply to me because I'm faster when I'm given the accelerators. So people will want those accelerators, but you shouldn't slow yourself down when you code when providing the accelerators. So what I've done is I've created a framework for adding accelerators as you go into the program. That's kind of an interesting framework, and it's based on nested reference data types known as anonymous inner classes, which we may have discussed a little bit last week. And so what I did was I created a way to map all of the polymorphic interfaces into a simpler interface. It's called the command design pattern, and what it means is every menu item knows how to run itself. I'll tell you that this is what I used to do. I'll show you what I used to do, I'll show you why it's wrong, and then I'll show you the right way. How's that? So here's a graphic program, an image processing program that, oh, the koala bear. Isn't that cute? So then, let's see if this works. Wow, it's very nice. I'm hitting Escape N for going to negate. It's very nice. So then, I've got the same sort of thing, low-pass filters, high-pass filters. Let's see if we can do a high-pass filter. Yep, works. Let's see, edge detect, Roberts, ooh, escape, ooh, there. It's very edgy. Every little tiny hair has become an edge. So, but it's still sort of recognizable, sort of. What I was thinking is that to get these menu items in here, what I would do is I would create a program that was very hard to maintain and very hard to modify. Let me show you something. These are the menu items. So if you wanted to add a menu item to the program, you went to the top of the program and you created the menu item. You added the menu item in with all of its shortcuts and everything, and even the string that goes with it, and that was fine. But then to get the menu item in to the interface, you had to actually add it to the frame, and you had to test it. So you had to go all the way down into where it says action performed. And then you wrote the giant dispatch. If this menu item was selected, then do that thing. So if you get the J2D thing, do J2D. If it's the prototype thing, do the prototype thing. If it's the HTML thing, do the HTML thing. So you had to visit the program at the top, then you had to go to the middle where action performed occurred. And you might even have to visit in a third place to actually add the menu item to the container that contains the menus. So as a result, you were visiting the program in too many different places. And it was too hard to maintain because these places got further and further away from each other in the source code. So I said, this is not scaling well. This is not easy to maintain. This is not a correct way to build a program. Then I said, aha, we've got to come up with a better way to deal with this. So I came up with a new system. And my new system said, look, if you want to add a new menu, you just say new run menu item. It knows how to run itself. That's the command design pattern. Then you provide an implementation for the runnable interface by supplying a run menu. So because every run menu item is abstract and implements the runnable interface, we expect you to have to provide a run method so the menu item knows how to run itself. Well, as it happens, in Swing, there are 22 major action interfaces that you can implement. So if you're doing a choice menu, then you've got to do choice selected implementations. If you do a state changed menu, then you need an item state changed implementation. If you want to do a button, then you have to do action performed. If you want to do a menu item, then you do action performed. In other words, you had to have a good knowledge of all the different components and all the different events that they could generate. Well, what I did by simplifying the events is I ended up creating what's called the facade design pattern, a simplified interface to the entire AWT and Swing, and I did it both in parallel. To effect that change took quite a bit of time, but I think it was worth it. So now if you go to the Run package, you can find an interface both for AWT and for Swing. And then I proceeded to build on that interface to make more runnable components. Here's one. It's an analog meter based on a number model so that you can sort of see the values as they change. Right? So all of these sort of runnable interfaces had to start with a name, so I gave them the name Run. Why not? So then I'd have a Run button, and it would be a button that knows how to run itself. Let's see if we can make it work. So here's the Run button, and here's cancel and OK, and here's a Run checkbox. And so when you add something like the Run button with an OK, here's the OK, and Alt-O becomes the accelerator because it's got a little left-hand square bracket. So the Run button knows how to interpret the left-hand square bracket. If you said, oh, I really want the A in cancel to be used so it can be Alt-A, then you just move the left-hand bracket over, and that automatically changes the way the cancel button appears. And so now you can see the A is underlined. And so what that means to me, the user, is if I type Alt-A, it does a cancel and hits the cancel button. And if I hit Alt-O, it does the OK thing, and Alt-H does the Chris thing, and Alt-K does the check me thing. So I don't actually have to click on anything, I can use the keyboard accelerators. That's part of, I guess, the elegance of building things in that way. Similarly, for the Run menu item, I have a whole series of, I'll call them shortcuts, that are global. The global keyboard accelerators like Control Alt Shift L, Control Alt Shift L, yeah, that actually works. So I can just go hold down Control Alt Shift L and just start hitting keys, and all the menu items will be selected. I don't actually have to go and select individual menu items. So that's kind of convenient. And you can sort of see how you can build a nice drawing program, or any kind of program really, using this technique. Let's see what else we got. Yeah, this is a run method as well. And at one point I had Greek characters in here so that you could have labels that would look like, how would you call it, equations. That kind of makes it nice. Here's a run font panel. Let's see if we can get that to work. So the run font panel, when you select a font, it should be able to get a value and it should give you a font instance. Let's see if it works. There you go. So the run font panel, it should let you pick out a font, and then you should be able to change the font size, and you can see the sample grow. Change the attributes, bold, italic. Change the color, green, okay. And change the string, IACTSW410 is great. And then when you're done, you should be able to hit OK. Now if you go down to see what's going on in the background, you can see a version of the instance that contains the font. That version of the instance of the data structure that contains the font is called the font bean. And the text which you see that describes the font bean is called XML. Okay, what's XML stand for? Yes, yeah, XML, Extensible Markup Language. So if you can save in Extensible Markup Language, then you can take the data that you're saving and you can transmit it for others to read. XML does for data what Java does for programs. It makes it completely portable, with limits. And the limits are, if the data is binary, XML does a very poor job of encoding it. An image probably isn't the right thing to put into an XML file, especially a big one. XML is really for transmitting text. Let's see now, what else do we got here? Oh, there's this font panel, and the font panel alters the data structure called the font bean. Right? So the font bean actually stores the value that the font panel creates. So that's the font name, the font size, and font attributes like italic and bold, font color. All of those things should be in the font panel. And sure enough, when we look at it as a data structure, we can see there are things like font style and font size and value. Those are the things we would expect from a good component editor. So the component editor, if we can reuse it in this way, will allow us to get information about an arbitrary font and present it to the user, and then use that data for whatever application we have in mind. So then the question becomes, how do you take this data and save it? How do you turn it into that XML that we saw? I mean, that's so important. And the answer is, it's serializable. Have you done anything with serializable instances before? Yes? No? Maybe? Sarisha? Serializable? Serializable instances are important because they allow us to obtain what's called persistence in Java. Serializable components are described in the book. Under page 192, which is part of the chapter on streams, which I had thought we had finished, but apparently we didn't. Serializable. If you have an instance of a class which is serializable, you can take that instance and convert it into bytes. Once you have an array of bytes, you can compress it using a gzip output stream. If you like, you can transmit it over the network. Or you could save it to a file output stream and then read it back in later. So if you have something like the payroll for your customers, you could make the payroll serializable. Then save it to the file system, and later you can open up the file, and you don't actually have to create a special format that you need to parse, because Java already knows how to do it. You can break it. You can break serialization, and you do that by adding a method, or changing its visibility, or adding a variable. Because a class is really nothing more than a cookie cutter, and if you change the shape of the cookie cutter, it won't fit the old cookies. The cookie cutter will just cut them off, or cut them up. So you can break serialization fairly easily. Take this and make it public. Take this and make it private. Serialization can't handle that. So if you're going to start making those kinds of changes to your classes, then you know you're going to be breaking serialization, and you'll need another method for storing. XML can do that. But once you've serialized, you can serialize not only to byte codes, to bytes, you can serialize to XML. And so that's a feature. Too much information here. In this particular code, I see a lot of interesting stuff. The preferences. Preferences are something that are associated with each user. So when you log in to a Windows system, you have your own preferences which are different than when I log in. Moreover, those system preferences are secure as Windows, for example, and allow me to store things like databases that include credit card numbers. I mean, that's secure. It makes for a secure file system. So what I can do when I go to the user root and get the preferences is I can get a value and a key, and I can put those things inside of the preferences as a simple hash map association. And that value can be an arbitrary array of bytes. So if I make a byte array output stream, what I'm really doing is I'm taking an array of bytes and converting it into an output stream so that I can proceed to write one or as many bytes as I like at a time, and it'll go into the byte array. And all it does is keep a pointer to the array, keep going to the bottom until you run out of array space, and then it just allocates more bytes until you run out of memory. Then this object output stream takes the serializable instance and writes it out to the byte array output stream in order to be able to take an instance of an object and convert it into an array of bytes. Once I write the byte array output stream and close it, I can get the entire byte array just by calling byte array output stream and calling to byte array. So now I've written this instance out, I've created an array of bytes, now I got to put it someplace. So because I've got your user preferences, what I can do is I can use an arbitrary key and take the value, the array of bytes, and just stash it in your preferences. So the next time you open up the font dialog box, the font bean can be restored, and I can set the font dialog box so that it can have the same values as the last time you used it. And that will be different than the last time I used it. Because when you log in as you, and you have your own user root preferences, and when I log in as me, and I have my own user root preferences. So two different people will not share the same dialog box settings. That's so important and so intuitive, because if you build a program, it should have reasonable defaults. And so this is a way in which to affect those reasonable defaults. And it's a good way, because what this says to me, you know, as a font bean user, is I don't actually have to worry about the font bean changing next time I run it. So if I run my little run font panel again, hopefully it will be set to the way it was last time I ran the problem. And sure enough, it retained not just the content of the text, but also the color, the font size, the text, the font attributes, the font name. All of these things were serialized to my preferences, and they will be restored back to the prior setting. Well, that makes perfect sense, especially if you've got a file dialog box or a special dialog box that has, let's say, a password or a lot of setup information, or a whole bunch of things that you want to set once and never have to reset again. So that kind of retention, that persistence of state, can only be obtained easily through serialization. I got a feeling that's too much information for you guys. But what I can do is I can give you some reading. So you should definitely be finished with chapters up through, let's see, 15, 16, 17. That'll be streams, readers, and writers. For preferences, I have an article which you can read, but I think you've got enough to read already. Don't you? Yes? Yeah, you're already you should be done with well, let's see how many pages. The first 280 pages of the book. So that takes you out through all of the Java language, files, streams, readers, writers, and swing. What do you think of that? I started to get into today chapter 20, on design patterns and events. And so to be really up to speed, you want to be going all the way up through page 327. So you've got a little bit of a homework assignment. You've got a bit of a reading assignment. I think it's not good for me to do too much new stuff today, but let me open the floor to questions. Are there any questions for the homework assignment due next week? Yes, of course. Yeah, if you have some questions and you want to shoot me an email, I'm happy to try and answer them. I'm more than happy to answer them. So ask your questions by all means. But because I'm here right now, if you have questions I can try and address, I will. Otherwise, I think I would let you guys go. Thank you very much. Enjoy the Java, and please send me an email if you have questions. Thank you.